Let's take this very simple example and understand what is the race condition and the data inconsistency in Java, in multithreading. So for example, let's say that we have one variable here. So we have a class race condition demo, and here we have a one static variable counter. And so what we do in our main method, so we are creating one runnable. So what runnable does is it just increments the counter, this variable, right? Counter, it increments that 1000 times. And we are creating two threads, thread 1 and the thread 2. And we are passing this runnable here, so this thread 1 and the thread 2 will do exactly the same task. They will increment the counter 1000 times, right? So we are starting both threads, and then we are calling a join, which waits until our main thread will end, right? So we are waiting until T1 and the T2 will finish. So what we expect here, what we expect as a result of this operation. So we expect that, okay, we have thread 1 that incremented it 1000 times. We have thread 2 that incremented it also 1000 times counter, right? So as a result, we should get the 2000. So now let's run it and see that do we get 2000 or not? Yes, we get to 2000, but let's increment. Let's add it. Let's make it not 1000, but let's make it 10,000. Let's make it 10,000 again. So thread 1 increments it 10,000 times counter, and the thread 2 increments also 10,000 times. We are expecting that this counter will be incremented by 20,000, right? 20,000 first thread and 20,000 the second thread. Let's now run it and see that. Okay, the result is unexpected, right? It's a 12,457. Let's run it one more time. Let's run it one more time. Again, the result, every time when we run this, the result will be different. Why it happens? So why this, for example, this one, right, getting close, it's a 19,952. Why we are getting this unexpected result? The reason why we are getting that, because in this case, we have one shared variable that is shared by the thread 1 and the thread 2, and they are updating this variable inconsistently. So what's that mean? So let's go and see that what exactly happens when we are updating that variable. So what we do from our side when we write a code, right, we just write it as a counter plus plus, which is that we are incrementing the counter. From the compiler side, compiler doesn't do this operation. From the compiler side, compiler just takes the counter and adds 1 to the counter. But what exactly happens from the CPU side? From the CPU side, this operation, the simple counter incrementing the counter, it's actually divided into the CPU performs that into 3 steps. What are those 3 steps? The first step is that the CPU loads the value of the counter from the memory into the CPU register. And the second one, it increments the value in the CPU register and then flashes back that value back to the RAM memory. So if we go to the visualize that, how exactly that happens, so we have a RAM memory, right? In the RAM memory, we have a counter. Let's say the value of the counter is 0. So how the CPU is organized? So let's say that we have a CPU with the 2 cores for the sake of simplicity, right? And each core, thread 1 is running in the first core, and the thread 2 is running on the second core. So with what we have in each core, right, in the CPU. So we have a registers, we have levels of cache, right, in the CPU. So we have the first level of cache, second level of cache, and third level of cache, and we have registers. So what happens? The first one is that this value, right, counter for each thread 1 and thread 2, this value is loaded from the RAM into the CPU register. So it's in the either threads are keeping them in the first level of cache, a second level of cache, doesn't matter, but they are loaded into the register for the first and the second one. And then each one, in each register, we are incrementing that value. Then we are writing back, flashing back that value, right? Whatever we are keeping that in the cache here, in the L1 cache, L2 cache, we are flashing back into the RAM memory. So what happens? What happens is that, let's say that the value is initially 0, right? So value is initially 0, and the thread 1 is set that value to thread that set that value to 1. And what we expect is if the second one will do the same, right? Second one should increment that, should make it 2, not 1. But what happens is, since it's loading from its cache to the memory, it just overwrites that value. So that value, this counter value, right, is 0. It becomes, so we are expecting that T2, right? T2 will make it 2, right? Will make it 2, but actually it overwrites that value, because for T2, that value is still 0, right? That value is still 0, and it overwrites that value. So that's why we are getting this unexpected result, and that's why we call it race condition, because we have one shared field, right? That is shared by both threads, and that they are overriding each other's value. So that's why we are getting this unexpected result. So how we can do that? Usually in, let's say, large projects and so on, so usually what we do is we are trying to avoid to having because if we know that that resource might, so if we know that it's not thread safe, so in that case we just try to avoid to have global variables. If we have to have them for one or the another reason, then we are using thread safe operations. For example, we are using synchronized and other operations which we will look in another episodes.